So good morning everybody. Welcome to Water Resources Engineering class. So mainly today's lecture focuses on how to separate the base flow. And if we separate the base flow, what's the remaining portion is. So that we will do in this particular lecture. Then most important thing is in this hydrographs, the first and foremost analysis is how to separate the base flow, because base flow and direct runoff are not reaching the outlet at the same time. So naturally it is my responsibility to separate the base flow and to tell what is the surface flow. That is why how to separate the base flow actually. So for separation of base flow, right, there are different methods. So what we are proposing actually, the hydrograph, storm hydrograph consists of three things: surface, subsurface runoff, base flow. But these two together I call it as direct runoff. So a storm hydrograph consists of direct runoff, direct runoff plus base flow. So now how to separate that base flow and find out what is direct runoff? That is the objective of our discussion. So what are the various techniques that are available for separation of base flow? The various things that are available for separation of the base flow are mainly three methods. One is a straight line method, the other one is two lines method, third one is curves extension method. You can ask me, why sir? Why means there is no actually unique factor between these two. The direct runoff reaches very fast to the outlet, whereas the base flow reaches very slow. So that's why I cannot analyze keeping that also into picture and move forward. So if I want to move forward, we need to separate the base flow from the storm hydrograph. So that is the first step in analyzation of the hydrographs. So now see what is the separation of base. Separating base flow from a hydrograph is essential in hydrology to distinguish the contribution of groundwater from direct runoff. Groundwater means what? Base flow. From the direct runoff means the stream flow or storm flow, resulting from a rainfall event. This is important in estimation of the actual runoff. You want to estimate the actual runoff, you need the direct runoff. How to get the direct runoff? First storm hydrograph you take it, separate the base flow, and then you get the direct runoff. That is what which we are studying. So what do you mean by a straight line thing? So already I showed the base flow recession, I told you already, right? So that base flow recession, you keep that point as 1. Similarly, the end of the recession limb also you note it. So what is that end of the recession limb? The end of the recession limb, straight away how can I know? Because the first one I can know because it starts rising. Where it starts rising, that is the starting point actually, right? So that I can easily note it. Whereas the end point noting is not that simple. How can I do it on the recession limb? So for that they have given us some calculation. This end of runoff will be after n days from the peak actually. From the peak, after a period of n days, the runoff ends. That is the basic discussion. So how to get this n days? To get that n days, we have an empirical formula. What is that empirical formula? N is equal to, for example, n is equal to 0.83 into a to the power of 0.2. So this is the equation. N is equal to 0.83 into a to the power of 0.2. What is A? A is nothing but area of the catchment, from which area the rain, whatever the runoff occurred to the outlet. So that is what area will be given to you. The moment area of the catchment is given to you, you calculate what is N. but remember that n will be in days. So note that n value. Once the n value is noted, after drawing the hydrograph from the peak, you represent that n days, and that point where it touches the hydrograph, you check it, and now this is the first point actually, and this is the second point. Now join these 2 points by a straight line. So below the straight line is base flow. Below that straight line is base flow or groundwater flow. Above this line is direct runoff, and this is base flow. It's as simple as that. You can go through each one quickly, but basically remember there are 2 points. Point A is what actually where the base flow recession comes down and starts. The moment rainfall occurs, this hydrograph starts rising. So that rising point, you note it. So that is point A. And what is point B actually? It is on the recession limb. Where it will be n days after the peak. What is that n days after the peak? N is equal to 0.83 into a to the power of 0.2. What is A? A is the area of the catchment. So knowing the area of the catchment, calculate what is n is equal to, identify the second point on the recession limb. Now join the first and second points. Once you join them, above that line whatever it is there, it is direct runoff, and below that line whatever it is there, it is base flow. So this is simple. See the graph also here actually. So this is the hydrograph actually, starting point. So A, and this is the end point. So end of runoff. How to get this the end of runoff? So from the peak it is n days, and n is equal to how much again? Tell me. 0.83 into a to the power of 0.2. So this is in days. Depending on that, calculate it. Once that is calculated, join these 2 points actually, and above this is called as direct runoff, and below this is base flow. So this is the first method. And then I will go to the second method. Second method is called as 2 lines method. What is this 2 lines method actually? Again the same way like how we represented the first point, here also we represent the first point A actually. Then afterwards what we are doing, the second point, how you are getting is the important thing. Now read this. In this method the base flow curve existing prior the commencement of the surface runoff is extended. So this line is extended. That is what the first point I told. Right, extended. Till it intersect the ordinate drawn from the peak. So from the peak, whatever line you have drawn, draw that from the peak actually. Right? It intersects. So this is C. Then again, end of runoff. How to get that end of runoff, you tell me? This is n days. Well, how to calculate n days? N is equal to 0.83 into a to the power of 0.2. So calculate n. So put this. So here just extend this base flow recession curve by a straight line. Draw a vertical line from the peak. Then note this point B actually, and then after noting this point B, then which is n days, that n is equal to 0.83 into a to the power of 0.2, and now join this B and C. That is the thing. So below ACB is what we call it as base flow. Above this is called as direct runoff. This is the second method. What is the third method? There is a small difference between the second and third methods. What is that second and third methods you see? Again, point A is common. Please remember always point A is the rising point of the rising limb, where rising starts actually, or end of the base flow recession curve at the beginning of the storm. So this is the first point. Second is not the peak. Forget about the peak now for a minute. Take the inflection point on the what you call it as on the recession limb. Take the which point? Inflection point on this actually. So that inflection point you take it and extend it. That is second. Once you extend that, where this line cuts it. So this is second point. The third point is the end of runoff. That is always same, n days, where n is equal to 0.83 into a to the power of 0.2. Use that and put it. Now join this. And below this is base flow, above this is direct runoff. So these are the three methods which we can do it actually. The same thing I will show in the graphs so that you can understand quickly. So direct runoff hydrograph. Now thing is time versus discharge. If you put it, the red one which you will get it. Then what is AB? AB is how the base flow is separated. So this is what we call it as base flow. What is this is called as direct runoff. This entire hydrograph is due to what? A rainfall of time duration D. Because of this is the result. And this result, base flow and direct runoff. Base flow separation you make it, then you get direct runoff. So if I see one is base flow separation, if I make it, you are getting directly the direct runoff. From here to this. Accepted? First thing is starting point is this. The outcome is this. And again base flow separation, this is this. And this is what we call it as direct runoff hydrograph. What you call this is called as storm hydrograph. A storm hydrograph, direct runoff hydrograph. From a storm hydrograph to direct runoff hydrograph, what should be done? Separation of base flow. How it is done? Three methods I told. Out of the three methods, which is the popular one? The first one itself actually. Right? The same I am showing in different way. Suppose you take it actually, suppose this is the rainfall intensity versus time we have given, right? Hydrographs and phi index I have put. So naturally from this the losses are subtracted. So this upper portion, whatever that upper portion is there, this is the upper portion. That is nothing but actually the effective rainfall hydrograph. Whether this or this, the area under this graph or the area under this graph, anything you take it, both really make one thing only. This is direct runoff volume. If anybody asks you the question, how to get the direct runoff volume, right? The area under direct runoff hydrograph is what we call it as direct runoff volume. So what is the area under the storm hydrograph? Under the storm hydrograph, whatever area is there, that gives you total runoff. Total runoff including base flow. Whereas if you separate the base flow, then you get volume of the direct runoff. The area under the direct runoff hydrograph gives you the runoff volume. Direct runoff volume. Please remember, excellent bit actually. Actually for this you need to refer again some more references also, and I referred the following three also while explaining the hydrographs unit actually. Number one is Engineering Hydrology by Rajesh Srivastava and Ashu Jain. Both belong to IIT Guwahati actually. Hydrology by H.M. Raghunath, very, very popular book, and Engineering Hydrology by Manish Kumar Goyal. Again, he also belonged to IIT Guwahati actually. So these three books also you can refer for this particular unit. Right? With this, thank you very much for listening patiently this particular unit. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.